Global and domestic economic pressures continue to create a climate of rising fuel costs. Competition from abroad for limited petroleum resources, changing EPA regulations, refinery capacity issues, as well as countless other factors are contributing to a growing awareness among fleet owners that improving fuel economy is an important factor in reducing operational costs.
Fuel savings is really the name of the game. The biggest cost to a trucking industry or a trucking firm is the cost of fuel consumption.
Dr. William E. Noonan's career spans 42 years, working on numerous engineering projects as a vibration and acoustic data analyst. His prestigious credentials include service on the NASA, Gemini, and Apollo projects, as well as F-4 and other fighter aircraft. Dr. Noonan discusses the variables in collecting fuel economy data.
Load, wind, tire pressure, air compressor leaks, air conditioning system itself, air filters, the efficiency of these air filters, and just the normal environmental conditions that a truck might see, which is the type of road, the hills, and the fuel itself, the quality of the fuel. All those parameters have a significant effect on fuel consumptions and consequently the cost of fuel consumptions.
One test method used to determine fuel economy and eliminate these variables is the dynamometer or dyno test. Dynamometer tests are accepted industry-wide for the reliability for determining fuel economy standards. Schaeffer Manufacturing Company, a St. Louis-based lubricant manufacturer, submitted their heavy-duty diesel engine oil formulations to a series of dyno tests over a 2-year period. These tests were conducted at several Caterpillar dealers using Taylor dynamometers, recognized throughout the industry for their reliability and consistency. The dyno studies were conducted to isolate and eliminate variables common in fleet fuel studies and were run using independent trucking companies that voluntarily participated. The dyno studies were designed to simulate stop-and-go driving with heavily loaded engines. The tests were conducted in a number of states throughout the country and staggered throughout the year to eliminate climate as a variable. Following each dyno study, Dr. Noonan evaluated the test procedure and data. The results of the dyno tests were consistent and provided solid evidence of the benefits of Schaeffer's engine oils, powertrain lubricants, and fuel additives.
The dyno test results using the Schaeffer product showed a 6.4% reduction in fuel burn rate, and that was over a wide range of test conditions.
Conventional lubricants have an irregularly shaped molecular structure. This base oil characteristic actually creates friction between the oil molecules. This friction restricts lubricant flow, resulting in decreased fuel efficiency, increased heat, oil degradation, and lubrication failure. The molecular structure in Schaeffer's synthetic plus oils has a more uniform molecular design that flows better, resulting in less fluid friction, better fuel economy, lower temperatures, and longer oil life. In addition to this unique molecular chemistry, Schaeffer's lubricants employ proprietary additives, including Micron Moly and Penetro. Micron Moly protects metal surfaces and reduces friction, further improving fuel economy and engine life. Schaeffer's proprietary additive Penetro acts like tiny ball bearings, enhancing the ability of the lubricant to reduce internal friction and improve fuel economy. This proprietary technology allows modern diesel engines to work more efficiently, delivering unmatched protection and proven fuel economy to fleet owners and operators. To confirm the results of the dyno studies in road conditions, Schaeffer commissioned a closed track study at the Transportation Research Center test facility in East Liberty, Ohio. The tests were conducted under SAE J1321 Type 2, which is a standard for measuring fuel economy. This test is designed to simulate over-the-road, long-haul operations. This EPA SmartWay-approved testing protocol requires numerous test cycles and repeatable performance over several days of testing. The test used 2 identical Class 8 trucks, fully loaded, driven around a 7.5-mile oval track. Schaeffer's proven technology delivered measurable results. After the data was tallied, the results showed a 1.9% improvement in fuel economy over a leading major brand competitor. This documented savings represents a significant return on investment, especially when rising fuel costs are taken into account and applied to an entire fleet. The combination of dyno testing and track testing proves that Schaeffer products save fleet customers money in all types of trucking operations. These documented results demonstrate that Schaeffer's friction-reducing technology improves fuel economy and cuts operating costs. Since 1839, Schaeffer products have been engineered to deliver proven performance. If documented fuel economy is something your company is interested in, you owe it to yourself to contact your local Schaeffer representative and experience the Schaeffer advantage.